Hello, everyone. My name is Matt Diocluse, General Manager of Rayco Rents. I'd like to thank all of you for taking the time out of your busy schedules to join us for our webinar on the real-time silica monitoring with the Trolex Air XS, accuracy, applications, and industry insights. Our presenters today are Dawn Anderson and Adrian Eccles with Trolex. During this webinar, they will cover the following: understanding real-time silica monitoring, technology behind the Air XS monitor, data logging and alarm systems, installation and best practices, and then at the end we'll do some questions if you want to throw them in the question box. Because of the large number of attendees, we are muting all attendees, and if you have a question, go ahead and put it in the question tool and go to webinar. We'll make sure those get answered. We'll be sending out a certificate of attendance after the webinar. We'll also be posting the recording and slides on the website. I've also put them up as a handout in a PDF version for now if you want to grab them, and we'll send out the link in the next day or two. Welcome, Dawn and Adrian. Take it away.
Hi, good morning, everybody. I'm Adrian. So we're going to go through some questions that have been posted already, so hopefully cover those in the presentation. But as was said before, if there are anything that I didn't cover or you want some more clarification on, please pop that in the question box and we'll answer that as we can going through at the end. So we're going to go through looking at sort of how the real-time silica monitor works, what we do at Trolex. So we're located in Manchester in England. We've been going for just over 65 years. We're a family-owned business, which is great because we have our own firmware, software, hardware engineers. We can develop products in-house, manufacture in-house, and then we can also support in-house around the world. So it's our founder is an engineer, so it's great having an engineer running a manufacturing business, so he can overhaul the accountant. So we've got three main products in what's called our particulate monitoring. We also do gas detection monitoring. We do different fluids, pressures, heat, temperatures, humidities, winds, which are typically used in underground mining and tunneling. But then with our particulate monitoring, it's opened up a wider audience from mining, tunneling, quarrying, aggregates, construction, manufacturing, and the hygienist market as well, to support those products in use and give good advice to how they can be used to work within the controls and check controls are working, or help develop new controls to keep people safe. So the three products we've got there, the Air XD is a dust monitor. It's about a foot square footprint. The XD1 is a personal wearable particulate monitor, so smaller than an iPhone in its footprint. And both those two are dust generic. They will just count the particles by particle size group and report on that. Where the Air XS on the right is a real-time silica monitor, so this will report what's going on in the work zone regarding silica. So we'll cover how it does that. So its basic design principle is to give real-time, instantaneous information. So whereas air sampling can be done for legislative, this can be given additional information so you can act upon that straight away. We can have short time periods, like from a minute. So if you was looking at a process and you really wanted to drill down what was causing the peak effect of that dust, you can have the rolling average on a minute, so you can see the real live data. We've been doing quite a lot of focus on kitchen worktop manufacturing, kitchen countertop, benchtop, depends on a local name for them. And in fact, Dawn was out last week with our hygienist in a site, and they were looking at doing some different types of cuts and how much dust they generated using different saws. And having the data available on that 1 minute period could really help with how they utilize them, how the extraction was working, and also then to look at how to improve the extraction to give greater protection. We can also do 15 minutes, 1 hour, 4 hour, or 8 hours, so you can look at a typical operator's rolling average throughout the day. The unit can display the warnings on the device, so you can set, for example, 0.05, so the US Silica level, if my memory is correct. Or you can do it at half that, you can do it at a fifth that. The unit's very, very sensitive, so you can set the alarms of what it can do. But as well as being able to display live readings on the screen, it can also connect into a factory or a mine or a quarry network system. I'll show some examples of that, so how you can really utilize live technology to get the best from it. I'll show you some images of what some customers have done. And also, if you wanted to put this in a report, the information's all downloadable to CSV file, and you can incorporate this into a report if you're doing a hygiene visit to a customer site and want to give them full data alongside the air sampling, give them some live data, what the air excess has seen. So how does it work? So if you think of the top of the unit, that's what the unit looks like. So it's about a foot square, its footprint on there. So the air goes through from the top into the laser, and this is a sensor here. So let's just see if I can share my webcam 1 second. So this is a typical sensor in our small portable monitors. This accounts dust by size. So that's the sort of scale of it, just so you can see next to my iPhone. I'm going the wrong way. There we are. Can't see work in reverse. So if we then look at the size of the sensor and the air excess, this is the size of the sensor. So there's a lot more going on with it compared to a normal particulate monitor, and there's a lot more workings on here. You can see these steel rods holding all the different lenses in pure alignment, and a lot more processing power going on with the unit. This is what makes it a lot different. See how that goes. So going back to the schematic here, the dust is going to come through the top, or the air is going to come through the top. We have a filtered sheath flow, which I'll come on to in a minute. It then goes into to be analyzed by the laser. So we've got a very, very focused point, and then we're looking at different readings coming off of this. And I'll go through that in a second of what they do. You see there, it can do 10,000 triggers per second. So if you think of a heavy dust environment, whether this be construction where somebody's cutting some concrete with a saw, we've all probably driven past roadwork contractors where they have the steel saws brand in the UK, but it's just a concrete cutting saw. Typically they have no protection, and they're doing a grimace as they cut away, and they're covered in a cloud of dust. So when you think about the air excess monitor, this can cope with 10,000 counts per second. So it's going to give you lots of information. So it's looking at particle count. We know the density of respirable crystalline silica. It can ignore the generic dust, and it's just going to focus on the respirable crystalline silica dust. And then the data it's going to push out at the end is going to be the respirable crystalline silica content in milligrams meter cubed. So we can see that for comparison between occupational levels, comparison to what the level is typically, comparison to what the level is that you're aiming for as a business or as a hygienist working within a business. How can you work with a site to improve the safety? Can this technology help you drive down exposures by having more information that you can act upon quicker and ways to improve the safety? So the air is going to come through and out there. You can see there's a filter here. We have one filter and another one just to the side. I'll show you a unit towards the end of the presentation. One filter is cleaning the air before it goes into the pump. We do this because dust particles inside a pump will cause damage and give it a short life. And then the second filter, once we've counted the air, any particulate contamination is captured on that filter. So we're not counting any dangerous respirable crystalline silica in our monitor and allow it to go back into the air to be breathed in. We actually capture it in the filter as well. So we're not allowing that particular bit of the air to go and harm somebody's lungs. So this is how it works. If you think of what I said about our standard small particulate monitor, that would normally just have a light source and a receiver. What we're doing with the air excess sensor, we're looking at counting the particles by size. We know the density, but then we're going to use something called optical refraction. So what you can see around here, this is very different to any other particle counter. Respirable crystalline silica has a signature pattern. And by looking at the light refraction from it, measuring the light absorption, we then couple that with a particle size and the wavelength of it, of what we send the laser out, we can calculate with these signatures the respirable crystalline silica content in milligrams meter cubed. If you remember what I said before, it can do 10,000 counts per second. So when you're thinking how much dust is out there and the dangerous dust we can't see, so it can cope with a lot of dust, and it can do it very, very quickly. So put that simply, the box on the left is a total air that goes through the sensor. We know it in litres because we know the size of our chamber. We know the flow rate of the pump. We then count the particles, but then we're looking at the silica content, and this is what we're going to report on in the milligrams meter cubed. So a question that typically get asked is, where should I site it? How much area will the monitor cover? What dust will the monitor see? How many units do I need? Where's the best place to site them? And put very simply, the sensor will see the dust that flows through it. So as it says on there, in a still room, and this is very hard to have a still room, you'd have to seal all the doors up, seal all the windows up, have no heat generation from radiators, from sunlight causing air currents to move. Then it would sample air from a meter. But just looking where I am in the room, I can see gaps in the door. We've got sunlight coming through. So all of this will be causing air to move. So when you are siting it, is to think, where is my most dangerous area that I know from previous air sampling or previous exposure? Where are my workers likely to be? It's no good just looking at the most dangerous area if no workers there. You want to look at where the workers are going to be in relation to that. The unit can work outside, it's fine in the sun, it's fine in the wet. We are in Manchester in England, we get a lot of wet. So it can cope with cold temperatures, hot temperatures. We have a lot of these units out on the big mines in Australia, where it's a lot warmer than it is in Manchester, where they can get, I'm trying to think of Fahrenheit now, where they can get 100 degrees Fahrenheit. So it can cope with the extremes of temperature. When we're looking at level of detection, it can go down to 1 micron size, and its smallest mass is 1 microgram. So it can be very, very precise in the data and the low level it can report on. Continuous loading, it can cope with 25 milligrams meter cubed all day long, every day. And if you're aware of dust loadings and dust levels, 25 milligrams meter cube is a lot of dust. It can also cope with max dust loads of 150 milligrams. So if we're thinking of maybe a quarry next to a crushing plant, if they've had the filters aren't working, the screening's not working, the extraction's not working, or even on a quarry when possibly doing an explosion to release more rock. So it can cope with very, very high levels of dust. So 2 different applications here on how it can work. So on the right is probably the best way to start with a product. So it can be mounted on a tripod. So the monitor weighs 8 kilos, so roughly 16 pounds. And on the tripod, it can be moved around the site either on AC power or DC power. AC power, it'll go from 100 to 240 volts, so it's fine wherever in the world you're working. DC power, 12 volts input on there. So say if it's a new construction site and you always wanted to do some boundary monitoring, you've got some vehicles creating the road in there, but there may be some residents nearby who are warning of dust issues, or there's a risk of silica from the rock content. You can move this around the site and have information on there. Or on the left, if it's more of an industrial process where you know what your main cause of respirable crystalline silica, you can have it set up so it's in one place. We say on the left hand side we can have data comms, so it's got Ethernet connection, it's got RS485, so it can go RS485 to USB, RS485 to Wi-Fi. We've got a 4G unit coming out very soon, or you can download the data at the end of the day, end of the week, onto a USB stick from this little screw cap here, the USB port. So you can take the data out and put it in our software and analyze that. And the data is also displayed on the screen, which I'll show you on a separate slide. This is a great way to start a typical application. Is people say to me is, how many do I need? And I'd say, well, just get one, and then work out what your worst areas are. And then if you need to focus and have more units on those worst areas, then you can do that. But I'd say just have one, understand what the exposure levels are around your application or applications, and then you can tune that in if you need to add more units later on. So the units are easy to start up. So once power is applied, it goes into its startup screen. Probably takes about 30 seconds to run the warm up and the self-test procedure, and then it goes straight into monitoring. On this one, where it's displaying 15 minutes, you'd have to have the unit running for 15 minutes to see that data. If I was to press the left arrow, it would then say 1 minute, and if the unit's been running for 1 minute, it would show that data. If I press the right arrow, it'd go 1 minute, 15 minutes, 1 hour, 4 hours, 8 hours, but it has to see that amount of time to report on that. It won't guess what it's seen, so it's not an analyzer, it's a monitor. It's going to report on actual data it's seen and report that on the screen and also the software. So again, this one here, bit of a zoom in, so it's running 0.04 milligrams meter cube on a rolling 15-minute average. What we can also do on here, the alarms can be set, so you can either go for the local legislative alarm, you can go for a company alarm. I know some major companies go for half the local level, or you go for a bespoke one you want to set as a hygienist, go to much lower levels. So it's got 2 alarms here. So for this one here, as an example, it's been set at a rolling 15 minute and the value is 0.05. So the unit, if the alarm's breached, will go red. We can have an external audio visual alarm sited here, or we can connect it into a factory system, which I'll show you soon. As well as being able to have those alarms, the monitor's also got 2 4 to 20 milliamp outputs. What that means is you can connect other equipment to it. You can connect switchgear to it. So if I think of my crushing plant at an aggregate location, if my alarm is breached, it can then turn on a secondary extraction unit, or it can turn on a water suppression unit, or it could even trip a switch to turn off the machine that's generating the dust. So as well as being able to give you the data, the unit can actually be set up to be an active in controlling other controls. So when alarms are breached, it's not just relying on somebody to see the screen. You can drive different behaviors from your extraction, from your suppression, turning the production site off. Okay, there's a typical clash with production saying, no, we can't turn that machine off. But if you can then look at ways of turning further extraction on or further water suppression on, we can then use the real-time monitor with real-time controls to keep people safe. And these can be set and configured different time periods, different exposure levels, of what is going to work best for you in your application, so you don't have to follow this example on the screen. This is an example of the data that's pulled out. So if you remember me saying earlier on about having the screw cap at the bottom where you can insert a USB into it. So I've inserted a USB into it. This device is our demo unit, and I'm looking at the 15-minute averaging period. I've got a line. I've picked a date where I now have got some information going on. So this is rolling 15 minutes. So I can see the time and date along the bottom. Up along the side, I can see milligrams per meter cubed. So you can see it's tracking along 10:30, nothing's happening. We get to about 11:45, now we see a rapid increase from 11:45 to 12 from 0 to 0.5 milligrams meter cubed. So obviously that's a high exposure level, 0.5 milligrams. What's caused that? So it could be, for my example, that the quarry bagging plant is producing a finer powder, which is creating more dust. And so we've seen an increase. And then somebody's done something manually, or maybe the project process is finished and you see a gradual drop. And then we see another peak again. So maybe it's a repeat of the process. But what we could have seen here is the site's introduced a control. So we're now tracking at 0.25 milligrams per meter cubed as against 0.5. So by having these really short time periods, you can really see what causes the peaks. And then if you can control those peaks, you can bring back lower the total level. And as an engineering process, one of my favorite examples is my quarry bagging plant. They have a huge shovel driver, massive machine. This shovel loads, I think it's 4 ton into a hopper to go through. But the hopper only just holds 4 ton, and the dust then billows down the side of it. And so what they did as an engineering control, they had some tarpaulin and some 2x2 wood and extended the height of the hopper. So on the next shovel of product that went in, the dust had to travel a lot higher before it could fall down the side. The shovel driver then said, well, I can put more product in. And the safety and the hygiene say, no, this is a control to improve your health. And after 3 goes of loading it and seeing about a quarter of the dust level by extending the height of the hopper so the dust doesn't billow over the side, they proved it worked. On the 5th go, the shovel loader ripped the tarpaulin and broke the wood. But then they could go to engineering and finance and say, look, we've done some testing. We've created a new control. Here's the screenshots of the data showing how it's worked, how it's lowering the exposure. Can we have some finance to enhance our controls to keep people safe? And having that information for finance and business cases allowed this site to get the engineering budget to improve the process and the safety of the individuals working within that area. Then if we look at that over an 8-hour time period, so we're looking at the same date and time, I'm now changing my setting drop down to an 8-hour average. And so if we just flick back here, so 11th of June at 12, where we're peaking, and midnight. So we're very peaking at 0.5. But then if we look at, sorry, wrong way. We're looking here, the background levels going on 0.005 milligram meter cubed. So it's tracking here 0.01, 2, 3, 4, 5. It's very, very constant. Then we see a drop down, then we see a steady increase. And then from here, we see a huge increase going up. So it's peaking just below 0.025. So if you were setting your site level at half the workplace exposure level, that would probably be very, very close to breach. Or if you was a third, you'd have breached it around here. So you could see that based on a rolling 8-hour average, it's far exceeded what was going on. So having the different formats you can view the data can help how you manage your controls, or how you just keep an overview on what the data's like. So you can see different ideas with it. This was another application where the hygienist reported that dust levels on conveyor belts, quite a common practice, where the material's traveling down a conveyor belt, and the hygienist had noticed that when the product was hitting the roller, they were seeing a spike in dust that was bouncing along. So engineering got some budget. They changed the rollers to a softer material. So as a product hit it, it didn't have such an impact. And so the dust level was lower. And again, it's a simple way of getting very quick readings to get the data to be able to say, yes, this has lowered the exposure level. And we can look at ways of keeping workers safe. Okay, and there's probably some housekeeping that needs to be improved in this one as well. This is an example of a factory. So this is a factory in Spain. They do have sites in the US as well, but this is one very recent from last year. So they've got real-time monitors, the dust monitors. They've got it. Remember I said about these 4 to 20 milliamp outputs giving data. So this is wired up to this traffic light system. So as an employee is going around a factory where there are known dust exposure hazards, they can see that this area is safe. Then if you look over here in the control room, there's lots of cameras and displays for the control room operator. He or she can then see the exact levels in different areas of the plant, the dust readings. Then over here, we've got like an alarm panel. So we've got 5 areas that are operating safe, green lights. Then we've got one area that's operating, and then that's known as area 27 on this example. So maintenance can go and look. The green light would have turned red on area 27. So this one outside would have turned red. The employees would be known to leave that area. It's an audio visual alarm as well. So not just a light, it does beep at 85 decibels to tell any workers in the area to remove themselves from that. Then maintenance and engineering can come and look at what's happened in this area. Has an extraction hose split? So the dust isn't being extracted as it should be. As an extraction hose coupling vibrated and come off, so they can quickly rectify the controls that obviously were working, but you can then see once they've failed, because it's going to give that instant indication based upon the alarms from the unit. So it's really proactive monitoring, not by the person. You set the systems up and the processes up, so that can help keep workers safe. Some of the questions that were asked before the webinar was about test standards. There isn't any standards around the world for real-time dust monitors. So we've done lots and lots of tests ourselves, but people often said if you had some third-party testing undertaken. So last year we had Bureau Veritas come in. Bureau Veritas are probably the world's biggest or most well-known, in my opinion. Maybe somebody else who thinks something different. Occupational hygiene provider. So they came in. This is our test cube in our lab. So it's a meter square, which helps with measuring particulate milligram meter square. So they set up 3 different test pumps, as you can see, left, right, on the right wall. The air excess is mounted in the middle. And they ran 8-hour testing of all the pumped units and the air excess. It's a sealed chamber. Dust is fed in from the top. I've got a short video to show that in a moment or two to show you how we do that. And then they got the data. So we've got the left-hand side, right-hand side, right-hand side, and the results over here on the right of what they were. And then down along the bottom is the results of what we had. This report, as you'll know, when you get hygienist reports, is a lot longer, and we can share all these afterwards with you. So I'll make these available to the guys at Rayco, and they can share these on with you as well. So you can get the full test report and read it through. There's no need to try and memorize this, or you can have a look at it at your leisure and then ask questions as well. So this was based at looking, we knew 30 milligram would develop readings around 0.05. So looking at exposure levels for the US, Australia, and other countries at that level. We then did it on a higher dose, so we went up to 300 milligrams. And again, we had the units in the same places, left, right-hand side of the test chamber. And again, we've got the readings here from the 3 pump sampling units that have been away for analysis, and then what the air excess did. So all the units are different. We're reporting slightly over. We quote a plus or minus 25% accuracy from continuous testing, and that falls within our accuracy figure for that. We have Bureau Veritas in again testing this month. They're doing 2 lots of testing this month, 2 lots of testing next month, and we're going to keep repeating that and getting more data so we can share more information on there. Going back to this one here, so this was developed around trying to replicate the exposure level for the US and Australia. We can go a lot lower, so I was on a call with New Zealand and their level is 0.025, but as some of you all know, that it can go below the limit of detection for air sampling. So we've tried to be fair and tested on figures that air sampling and real-time monitoring can both work in the same area. Again, I will share these, so if there are any questions, you'll get to read them in full detail. We had a couple of new appointments last year. In September, Fahim joined us. She has a doctorate in soil erosion analysis. So she's leading our lab management and testing. So with the help of Joe, who joined us in October. Joe's an occupational hygienist, 15 years. So we're going to look at the theme, and Joe are going to write a white paper. And part of that is we're going to do lots more lab testing. We'll continue to do our own lab testing with him doing it. We'll continue to do the lab testing, Bureau Veritas coming in. But also we're sending Joe out into the workplace. So as you hygienists on there, typical setup, a pelly case for the pumps, sampling heads, is going out into different workplaces, doing side-by-side monitoring with our personal monitor, sampling head, and also within the workplace of the air excess. And yes, I know this is area sampling and not personal sampling, but we're trying to give indicative information of what they're seeing so we can give a greater picture of how they work alongside each other. What do they look like? And so we're getting a balance of different data from our lab, which is a test cube, which is very, very controlled, to normal working environments. So there's been a big focus on kitchen worktop, counter worktop, bench top manufacturing. So Joe's been out doing a lot of those, but he's also going to look at construction. He wants to look at manufacturing, woodworking. Okay, the Silica monitor wouldn't be for that, but for different monitors. So we're just trying to create a big picture of data that we can share to show how the unit compares, whether we then need to look at how mounting of sampling heads compares with monitoring. So we can share lots of information with you and have a basis of internal lab testing, Bureau Veritas lab testing, field information. Then Fahim and Joe will create a white paper on this, and then let's go out for peer review. Some of you guys may get involved in that, hopefully. But it's by more and more data to show the accuracy of the units, the reliability of the units. I think that's one thing I saw on LinkedIn. Somebody mentioned about our accuracy of the PID monitor, and somebody responded. I wish I took a screenshot of it because I can't remember. And they put, if your exposure level is 5 parts per billion and you've got 1 part per billion, then things are okay. If you've got 300 parts per billion, you've got an issue. So it's about identifying your normal has changed detrimentally to the health of the workers in that area, and being able to do something about it very, very quickly. And this is what we're seeing with the real-time monitoring, from something personal like the XD1 Plus, which will beep, flash, and vibrate if an alarm is breached. This one is non-dust specific, so it won't tell you what the dust is. It will just tell you that the level has been breached. As you remember back to that sensor size, we need a lot more power and size with the air excess sensor to make it be able to do its calculations and analysis. What we have here, we've been doing, so this is a video. This is Fahim doing our testing in a lab. So we have some dust sample going in. I apologize, this screen's a bit small. I will share a link to these videos for you. Fahim, then we've got a compressor just down here on the left. Fahim will connect the compressor, and then you'll look for a dispersal here of the dust. I don't know how easy that was to see. So when a compressor goes in to disperse the dust into the monitoring chamber, I'll do that again. I will share a link to this or get it up on our company YouTube so you can see this in a bit better detail. If you focus around here, hopefully you can see that, but like I said, I will share that. At the same time, we had one camera looking an overview on the chamber, and we had a second camera pointing directly on here. And again, sorry, these are too small to see very well, but it's currently showing 0.000 milligram meter cubed. And we hear the sample going in as we flick through. So we're now at 0.920 milligram meter cube on a rolling 1 minute average. And then that's going to go, so you can see the data really, really quickly. And now I'll change up to 1.3. But I will share these so they're easy to see. We had a couple of visitors in our office a few weeks ago from University of Manchester. So Mike on the right is a lecturer. Bizarrely, coincidentally, he also taught Joe some years ago. And Joe, my colleague, the occupational hygienist. So Mike is a lecturer at University of Manchester. Johannes is a researcher. So they've got interest in showing new technologies to their students. So we came and gave them an overview. As we're a Manchester company, we'll loan them a unit they can use to educate the next generation of student coming through, so we can get that next stage of technology involved in part of the curriculum, and so they can be aware of what's going on and being kept up to date with developments of what's out there. That's the end of the presentation. What I'm going to do now is share my webcam. There's a couple of questions beforehand about testing, so we're just going to go for a little walk. 1 second, if I can do this properly without dropping you. So the monitors there. So somebody put in one of the questions, what maintenance or testing does a unit need? So every month it needs a compliance test. So we have these bottles of sample dust. So within these, we have some small bottles. Then you would tip that into an aspirator. Inside there, you'd violently shake this, give it a good bang. We have a cover going over the unit, and then we'd apply the dust in the test process and go through the test process. So this is a compliance check that's due every month. We have a kit that has all the products and samples you need for it to happen. And also as part of that, once you've completed the compliance test, I mentioned the filters earlier on, but the filters would need changing. So you pull the filter forward, pop the filter off, change for a new one, dispose of carefully, and then refit the filter. Do it on the second side, and away you go from there. We can see the outputs down here. So these are 4 to 20 milliamp outputs I spoke about, where it can start up a secondary extraction system or a primary, depending on what's going on. Or it can do the external audio visual alarm. Got the Ethernet communication port. Got the RS485 output, so you can go to Wi-Fi, to USB, into a network system. And also under here at the back, we've got the USB port, so you can insert USB into here and download data on there. So you can get the outputs from that. See the size of the unit. It weighs about 16 pounds, so you can move it around site fairly easy. I wouldn't want to wear it. It's not a wearable monitor. It's a semi-fixed monitor where you can take it to different places around the factory, construction site, wherever you're working, and get the live readings of what people have been exposed to. And the data will show on the screen. There we can see it showing the live reading, 1 minute sample, the 15 minute, the 1 hour, the 4 hour. It's not being run for 8 hours, so it won't give me that information. So I had this on this morning when I came to the office. So it's only going to show me that data. I'm very pleased to see we don't have respirable crystalline silica issue in the office, but you can see how low it can go, 0.00 milligrams. So it can give you very, very precise data on what the area or the workers are being exposed to. And they can look at your controls, making sure they're adequate and suitable, or whether there's been environmental change, different wind direction. Maybe there's been a fire nearby and the fire brigade are taking all the water pressure. So your water suppression, you are getting some water pressure, but it maybe dropped from 2 bar to half a bar. And the control you had in place maybe isn't working as adequately as was thought. So things like that can really help with. So I hope that helps with some of the questions that were answered before.
Adrian, we've got a couple others, if you don't mind, really quickly. One that came up is intrinsic safety rating.
It's not intrinsically safe. So the temperature that the laser operates at wouldn't pass intrinsically safe rating, no. Okay. It's a general purpose unit.
Next one is, I'm assuming this would give you milligrams per meter cubed. Yes, for all forms of silica present as total RCS count, not specific forms of silica.
No, it won't identify the difference between them. It's just going to report total RCS.
Mm-hmm. Is the wearable monitor measure respirable dust, total, or both?
The wearable monitor reports on PM1, PM2.5, PM4.25, and PM10. So it's reporting on respirable and lower end of inhalable. I know inhalable can go up to PM100, but so it's good at respirable and it'll touch slightly into inhalable.
Are you developing a personal RCS real-time monitor?
We would love to say yes. The AirXS took us 9 years to develop. And going back to what I said at the start, it being a family business run by an engineer, I've worked for global MSA before. And if a product working for a global PLC like that wasn't in the market within 3 years, there'd be lots of people leaving the business to start new ventures was a standard email. And a product wouldn't come to market if it wasn't in 3 years. So luckily, being a family-owned business run by an engineer, we could spend 9 years developing this. We'd love to say yes, but this is the size of the sensor. So that's just a sensor alone. Compare that to the sensor in our personal monitor. There's a lot more going on within this. So maybe in 10 years, who knows? But at the moment, we're the first company in the world to have a real-time crystalline silica monitor. So it is fairly big, but it can be moved easily around the site on a tripod. It's been put in different areas to where people are working to give indicative information of what they're being exposed to. I'd love to say we're going to develop and launch a personal one tomorrow, but it's just not practicable at the moment.
What alarm set points are IHs using still half TWA?
We tend to see, so if your workplace exposure level is 0.05, we tend to see a lot going for 0.15, going for around a third of it, and then looking at as an action level, as would be typical in different exposures as well. So we always say to people, don't allow it to get to the exposure level limit before doing something. So as a hygienist will know out there, always set it a lot lower.
Is the unit waterproof, water resistant? It sounded like it. What other materials that could influence the RCS? In a quick review of density, what are the effects of the request with limestone or calcified clay within the dust particulate matrix?
Well, the refraction index of crystalline silica and its signature are very specific, so we don't see any cross sensitivity.
Most consulting firm IT departments don't give admin rights to install software. Is there a web-based version of the Trolex software?
Yes, we do have this issue where IT companies won't allow some software, and we have passed the Microsoft Store security. So Liam, who's our software engineer, has gone through all the different security checks. We have the UK military user unit and the software, but it is sometimes a sticking point, yes, where the IT say, no, you can't allow this system. So we are just about to launch the 4G version, which will go to a cloud system.
Okay. Is there a comparison chart for...
We tend to find when you have the discussions with IT and say, this is what it's for, they can ask us lots of questions on security. Liam, our software engineer, will fill out forms on what it does, what it doesn't do. And we tend to be that 95% of the time people do get it allowed onto their systems.
Okay. Is there a comparison chart for background sampling with PM10 or TSP monitoring?
No, but one of the things we're sending, so on the pictures where we had Joe out in the workplace, where he had the air sampling pump, our little personal monitor, and then the air excess. Okay, they're not directly next to each other, but we're going to give some indicative information. We can pull the PM10 data off the personal monitor. We can then compare that to what the RCS monitor was seeing and give some indicative information on there.
Okay. Would water aerosols interfere with the detection? Many apps use water to suppress dust, but RCS exposure still can be significant.
Yeah.
Related to that, do high moisture environments affect the measurement?
Okay, so we test up and it's proved 0 to 95% relative humidity. Water suppression, say, used in demolition contracts with a fine mist spray. The unit can sit outside in the rain all day long, but we also just say to think how you're siting it, to where the dust level is, where the water spray is, where your staff are. So if you've got a demolition, what's the term? Not a shovel driver, a brakey. I don't know what the term is here. Machine breaking down a concrete. And then you've got the water spray on there, but you've got other staff manually going through. It's to position where the workers are and where they're exposed to. Most of the big plant these days has got really good air filter systems within there, and so it's generally people outside who are careful positioning, see what they're exposed to.
Okay. Last question. Did you cover accuracy?
Yeah, our quoted accuracy is plus or minus 25%. There's a number of reasons for that. Is one, we can never stop one particle mirroring a second particle as it goes through. So we have to have a tolerance level. It's very, very infrequent, but there is always a chance for it to happen. So we build that in. Our testers that we buy for product development testing is optically counted under a microscope, and they quote a plus or minus 5% accuracy. So we then have to build this in. But by having more real-time testing undertaken, more lab-based analysis undertaken, so we can share the data, and share the data, people be able to see reliable information. We want it to be accurate. There's always going to be a small movement on there. If you think back to reports from the pump sampling in the test chamber, so a calm test chamber, there was differences between the pumped air samplers. So it's about people understanding what their normal is and then looking for any changes that are causing harm, or understanding what your normal is and how you can help reduce that by using the technology to find where the worst source of the exposure is and how to keep people safe.
Okay, I've had a couple questions on pricing. I just say in general, you're looking at almost $20,000 by the time you add all the transport pack, the compliance packs, spare batteries, that kind of stuff.
Yeah.
All right, yeah, that'll do it for us today. Dawn and Adrian, thank you very much for your presentation. If anyone has any specific application questions, feel free to give us a call, 866-RENT-EHS, 866-736-8347. You can also reach me by email at matt@raycorents.com. If you want to know more about the technologies we supply, please follow us on social media. We've got lots of good technical tips at the blog.raycorents.com. You can also follow us on LinkedIn. We do record all these training sessions, which you'll find on YouTube. And if there are any topics you'd like us to cover, please email me, again, at matt@raycorents.com. At this point, no further questions. Our presentation will conclude. Thank you all for attending.
Thank you, everybody.
For the
Have a good day.
Thank you. Bye.
Bye.